Hey guys, this is obviously the second part of the first unit, and it's differentiation. So we're obviously going to be expanding on what you already know, but what you already know is going to be important here. So everything that you did on differentiation last year and higher, you're going to need to know for what we're going to look at throughout advanced higher. So everything from differentiating trig functions, putting things into differentiable form first, all those kind of things you're going to need to know to be able to do what we're moving on to. So I suggest if you've got kind of a mind blank, when I start speaking about differentiation, you go back and have a look through some of what we've done. I'm going to give you a lot of time to do this first assignment. So take the time to go back and look at differentiation if you need to. If you don't feel like you need to, then don't bother. Your memory might be jogged by this first bit anyway. But as I say, it's what's going to be expected knowledge, what you've already done. And because you've not come in from an exam, you've not necessarily had the same kind of preparation as people maybe do at this stage usually. So take your time to go and prepare for this differentiation part by looking at what you've done last year. Okay, otherwise I'm just going to move on. So first part is chain rule. Chain rule you actually did in higher. But you learned it in a very, very basic way. If you had something like this 5x plus 1 cubed, all you really did was you stuck the 3 at the front, you multiplied by the derivative of generally you just multiplied by the number that's in front of the x, and then drop that by 1. What you're actually doing is something a bit more complicated, and obviously when you've got something a bit more complicated than these, you're going to need to know what you're actually doing with the chain rule. Some of you might have looked at this last year, but obviously we're going to look at it a bit more detail. Generally what we're doing when we're using the chain rule is we're finding the derivative of a function of a function, so composite functions. You looked at composite functions again last year. It's not really going to help you looking at that just now, but we're going to need to know how to differentiate, and I'm going to expand on what you did in terms of chain rule. Okay. What you're going to find with differentiation is there's lots of different types of differentiation. So you've got the chain rule. We're going to go on to the product rule, the quotient rule. And again, similar to the kind of idea with partial fractions, is you need to know what to do in each of those situations. But more importantly, you need to know which situation it is. Okay, so spotting the chain rule can be quite complicated. So in terms of looking at a composite function for what a function of a function is, that might be worth 5 minutes of your time. But hopefully you'll pick up through these first couple of examples. But it's basically when you've got something's happening with x. So for this x, for example, it's been times by 5 and then added on 1. That's one function. Then that whole thing is being cubed. So that's what we mean by a function of a function. So this function, the x is being times by 5 and plus 1, and then it's being cubed. For this one over here, it's being times by 2 and then add 1. That's one function, and then we're finding the cosine of that function. So it's a function of a function. What's going to happen later on is we're going to have functions multiplied together, and you need to know the difference. Okay, so another thing to think about is how functions are relayed to you. So it might be in terms of f of x, it might be in terms of y, it might be g of x, k of x, it could be anything. Okay, so because of that, there's different ways of writing the official version of the chain rule. So this is how you might see it sometimes. Okay, this is not the version that I'm going to use, but this is basically saying, because what's going to happen when we do find the derivative of a function, so we do apply the chain rule, is we're going to get a new function. So we're just calling it k dash x here because it's the derivative, and that's equivalent to f dash g of x times by g dash x. But that can be a bit complicated, and there's a lot of things that can go wrong with that version. Okay, so I tend to use this version here. Okay, and as I say, you might have actually seen this last year. The dy by dx, which is obviously just the derivative, is equivalent to dy by du times by du by dx. Right, the first thing to think about here is what all of these things mean. Okay, and I know probably some of you just kind of ignored last year what all of this means, and you just associate that with differentiation and you just write it down. You really need to think about what it actually means in advanced higher. So what we're basically saying here, in terms of dy by dx, that's the rate of change of y with respect to x. So it's the function y being differentiated with respect to x. Okay, that's what that means, and that's generally what you do. Okay, if you think back to higher, you had a function y equals 3x, for example, and when you differentiated it, you differentiated it in terms of the x. So that's what that's saying basically. Okay, over here that's not the same. It's not the same letters, so these mean different things. So what this first one means is the function y being differentiated with respect to u, and the second one is the function u being differentiated with respect to x. Okay, that's important obviously for what we're going on to. And what this basically means is that there's going to be a function in terms of u, or there's going to be a u kicking about. Okay, generally these functions in the first instance aren't given to you with a u in them. So what we're basically going to do is we're going to create a function in terms of u. We're just going to label a function in terms of u. It's going to help us with our differentiation here. Okay, so that's the version that I'm going to use. If you want to use the other one, that's absolutely fine, but this is the version that I'm going to use. Right, it does get more difficult. I know you're probably thinking it's difficult enough as it is, but what we may want to find, this is dealing with a function of a function, okay, but what we may move on to is dealing with a function of a function of a function, okay, and obviously the whole point of this is that we're going to differentiate that, okay, so we can basically expand this form and we can find the function, the derivative of a function of a function of a function, and it will look something like this, okay, so similar kind of idea, we find the derivative of that first function, so we want to find dy by dx, the function will be y equals something in terms of x, we want to differentiate it with respect to x. So what we do is we define dy by du, we define du by dt, and we define dt by dx, and we multiply them. Okay, so we've got this u again, but we've also got a t. So all that's going to happen here is we're going to take one of the functions within our function, and we're going to label it u, we're going to label the other one t. All this will make sense in a second once I show you an example. Okay, so if you need to come back to this slide, and it might make more sense once you've seen an example. So I'm just going to go straight into an example. Okay. So very straightforward, find dy by dx when y equals cos squared 3x, right? Another thing that's going to be important here is knowing what these functions mean. Okay, so you should be able to look at y equals cos squared 3x and know what that means. Okay, so obviously that's just a kind of a shortened form of cos 3x all squared. And you need to know that because it's in terms of the order in which the function is being applied. Okay, so what this means is the square of the cosine of 3x. Okay, so there's three different functions right there. So we're taking the x and we're timesing it by 3. That's the first function. Okay, then we're going to find the cosine of that function, and then we're going to square that function. Okay, so we do have three different functions here. So what we're going to do, because none of these are labeled, the whole thing is labeled as y equals cos squared 3x. But basically what we want to do is we want to break them down and break them out into individual functions. So I've written it like this, but I always do this in reverse. So I take the first function. So x has been multiplied by 3 first. That's a first function. I'm just going to label it t. Okay, it doesn't really matter what the letters are here. You just want it to kind of be labeled almost like an equation. Okay, but the second one, basically once we take that t, okay, so once we take that 3x, sorry, and we find the cosine of it. So we find the cosine of 3x, or now it's the cosine of t. That's our second function, u equals cos t. And then what we're going to do is we're going to take that cos t and we're going to square it. So we're going to take our u and it's going to be squared. Okay, it might take you a wee while to get used to this, okay, but this is important in terms of the way of writing. Right, what we're going to do in terms of the formula that we had before is we want to find these three things. So if you remember, the formula was dy by dx. That's what we're trying to find here. We're trying to find dy by dx. And what we want to do is basically differentiate each one of these individual functions. Okay, so this is where you might need a little bit of revision of your differentiation. But if you've got y equals u squared, the derivative of that is 2u. Okay, when you've got u equal to cos t, the derivative of cos t, and this is important to remember your trigonometric differentiation, is minus sine t, and the derivative of 3x is just 3. Okay, 2u minus sine t, and you've got 3. Okay, so write these down as it is just now. This might be a little bit time consuming until you get used to it. Once you get used to it, this becomes relatively straightforward and you don't necessarily need any of these steps. But just now, let's just get used to how this is all written. Okay, so to find dy by dx, it's these three functions, these three derivatives multiplied together. Okay, so it's 2u times by minus sine t times by 3. Right, the problem with this is not a function in terms of x. Okay, so generally when we differentiate something in terms of x, we want our derivative to be in terms of x. So what we need to do now is we need to simplify this a little bit, plus we need to add back in our u and our t. Okay, we created them out of nothing. We put in the u, we put in the t. Okay, we said them, and although we've made it clear what they equal, okay, our answer needs to be in terms of x. So what we need to do now is we need to substitute them back in, and this is an often forgotten point of this chain rule exercise. Okay, so I'm going to do this with some sexy PowerPoint animations now. So hold on to your horses. Right, simplify that a little bit. It's basically just 6u or minus 6u times by sine t. Okay, but obviously we've got that u and a t involved there. So I want to take them out. Oh. And I know from earlier that u equals cos t. So I'm just going to replace that u with cos t. Look at that. Okay, but now I've got these two t's. I don't want the two t's, so I need to replace the t's with the three x's. So I take the two t's out and I replace them with three x's. And that there is basically your final answer. Okay. As I say, once you get used to this, you might be able to do that in a much simpler form, but you need to know where it's come from. You need to know how it works, and be able to get to this point. Right, if you look at answers, you might find that this is given in a different form. And this is one of these things you're going to find more and more with advanced higher is what is the simplest form? What form are they looking for the answer, right? It's very ambiguous. I don't necessarily know the answer to that. I think this one would be fine. If I was marking anything, I would be fine with this. But what you might find if you're looking at answers is you get things like this, okay? So again, what's going to be important throughout advanced higher is your trig identities, okay? And all the different double angle formulas, all the things that you learned last year. So from last year, you saw that sine 2x was 2 sine x cos x, in which case if you had something like 2 sine 3x cos 3x, what that would be equal to is sine 6x. And that's kind of equivalent to what we've got here, okay? In which case we could, if we wanted to, simplify it to minus 3 sine 6x. As I say, for the purpose of this, that is fine, that answer is fine. But just in future, if you're checking answers, you might find that the answer given in a textbook is something like that, and that's how you get to it. Okay, obviously in some instances it might be better to have it in this form, it might be better to have it in this form. That's where, as I say, the simplest form idea becomes a little bit ambiguous. Okay, I'll give you one more example. Okay, so we're going to find the derivative now when y equals 1 over sine squared 3x plus 1. So again, what we've basically got here is we've got it not in differentiable form. So this is what I said at the start. I said you want to kind of look at changing these kind of things into differentiable form. Okay, so if it's 1 over sine squared 3x plus 1, basically what we want to do to write it in differentiable form. So in a form that with which we can differentiate, it would be something like this. It's the sine of 3x plus 1, and it's all of that basically to the power of minus 2. Okay, so when you're writing sine squared 3x plus 1, what that means is the sine of 3x plus 1 all squared. If it's 1 over that, then you can write it as a negative power. And this is now in differentiable form, and now we can start splitting it up and using the chain rule to actually find the derivative. Okay, so again, you're trying to find your three different functions. Okay, so I would almost do this in reverse, as I say. Start with a very basic form. Find your x and find out what's happening to it. So the x is being multiplied by 3 and then adding on 1. That's the first function, so I'm going to label that one t. Okay, then we're going to take that function, we're going to find the sine of it. Okay, so now that 3x plus 1 is t, what we're going to do next is we're going to find the sine of t. That's our second function, so u equals the sine of t. I'm going to take all of that and we're going to find it, do it to the power of minus 2. So we're going to take that u and we're going to do it to the power of minus 2. So there are three functions. Now we're going to find the derivative of each one of them. Okay. So when we differentiate a negative, you've got to be very careful again. So negative 2 goes in front, you're dropping it by 1. 1 less than minus 2 is minus 3. So it's minus 2u to the power of minus 3. Again, trigonometric functions. The derivative of sine t is cos t. And if you have something like 3x plus 1, the derivative is just 3. Sticking all these together, it's just a case of multiplying it. You get something like that. Simplified down, you get minus 6 cos t u to the power of minus 3. Okay, probably shouldn't actually write it like that because that's bad form. That's implying that's the cos of all of that. So sorry. But when we simplify this a little bit, basically what you want to do is you want to take out the t, you want to take out the u and replace it with what you've got. Okay, those sexy PowerPoint animations take me a long time, so I haven't put them in here. But if you can notice, if I take out the u first of all, this would become minus 6 cos t times by the sine of t all to the power of minus 3, and then replace the t's with 3x plus 1. I get minus 6 cos 3x plus 1 sine 3x plus 1 all to the power of minus 3. And dealing with this, okay, the minus 3, it's the same idea as what we had at the start, basically just stick it on the bottom. Okay, and it simplifies it a little bit. You can put the minus in front, simplify it even more, but something like that is all that we're looking for. Okay, so that's the idea of chain rule. Okay, I'm going to give you a bit of time to do this, so I'll give it into next week, but don't just leave it till the last minute. Okay, have a look at differentiation from higher if you need to, just to kind of jog your memory. Also, what I've done on the end of this PowerPoint, I'm not going to go through it because it's not important. You don't necessarily need it for what we're doing, but a lot of you probably don't really understand what differentiation actually is. Okay, so if you want to know what differentiation is and where it comes from and how it all works, we've got differentiation by first principles. Now, some of you might have looked at this last year, but I've put it in a bit more detail on the next few slides. So I'm not going to go through them because it's not important, and I know I'm just going to confuse you and scare you even more if I do. But if you're feeling a little bit saucy and you want to go through them, then have a look through those PowerPoint slides and get a feel for differentiation by first principles. If any of you go to university and do maths, it's going to be important. But just now for, for advanced higher, it's not so important. So don't worry about it too much. Okay.